11th mathematics exercise 9.4. Find the sum to n terms of each of the series in exercise 1 to 7. Question number 1. 1 into 2 plus 2 into 3 plus 3 into 4 plus 4 into 5. Now if you see, this is the first term, this is the second term, this is the third term, this is the fourth term, and so on. And we can see that the first term is composed of two numbers. Similarly, second number is also composed of two numbers. Third term is also composed of two numbers. Fourth term is also composed of two numbers. So if you take only the first term, it is composed of two numbers. So if you take the first part, that is 1, and similarly in second term, if you take in the first part of second term, that is 2. Third term, also if you take the first part, that is 3. Fourth part, if you take the first part of fourth term, if you take the first part, what we are getting is 4. So we can see that it is an AP. Similarly, if you see the second part of first term, that is 2. Second part of second term is 3, and second part of third term is 4. Second part of fourth term is 5, and so on. So we can see that is also an AP. So we can find the nth term of this series by an equal to that is composed of two numbers. We have seen that an equal to nth term of the AP 1, 2, 3, so on till 4, multiplied by nth term of the second AP, that is 2, 3, 4, 5, and so on. So therefore what we are getting, an equal to first term is 1, second term 2, third term 3, fourth term first number is 4. So then obviously in the nth term the first number will be n into. Similarly, the second number in the nth term will be, here you can see that in first term second number is 1 greater than the first one. Second term also the second number is greater by 1. Third term again the second number is greater by 1. Fourth term second number is greater by 1. So we can say that an equal to n into n plus second number in this case will be n plus 1. So therefore we are getting an equal to n square plus n. And what is Sn? Sn is nothing but summation of an. Therefore we can say that Sn equal to summation n square plus n, and this is n total, so we'll keep that in bracket, and this implies Sn equal to summation of n square plus summation of n. Therefore Sn equal to summation n square means the sum of the squares of first n natural numbers, so that is n into n plus 1 into 2n plus 1 over 6, plus what is summation n, that is n into n plus 1 by 2. Therefore Sn equal to, now in both terms what is common, n to n plus 1 by 2 is common, so n into n plus 1 by 2. What will remain here is 2n plus 1. In the denominator we have taken 2 already common from here, so it will be here 3 plus, and here 1. So therefore Sn equal to n into n plus 1 over 2. Simplifying this, we will be getting 2n plus 1 plus 3 over 3. So therefore Sn equal to n into n plus 1 over 2, and this will become 2n plus 4 into 2n plus 4 by 3, and from this second number which is being multiplied here, we can take out 2 common. So therefore what we will be having is Sn equal to n into n plus 1 by 2 into 2 multiplied by n plus 2 over 3. So 2 and 2 cancel out, and what we will be getting is, therefore Sn equal to n into n plus 1 into n plus 2 over 3. So this will be our sum of the n terms of the given series. Exercise 9.4, question number 2. 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus so on. So solving question number 2. Now here we can see this is the first term, this is the second term, and this is the third term, and so on. So in each term, three numbers are being multiplied. We say the first number in each term, we see that we get a sequence 1, 2, 3, so on, that is in AP. Similarly, if you take the second number which is being multiplied in each of the uh, term, that is 2, 3, 4, that is also an AP. Similarly, if you see the third number which is multiplying in each of the term, that is 3, 4, 5, so it is also an AP. So therefore, we can say that in this case an equal to nth term of the AP, nth term of AP 1, 2, 3, so on, multiplied by nth term of AP 2, 3, 4, and so on, and into nth term of the AP 3, 4, 5, and so on. So that is equal to an equal to, so the what is the formula for the nth term, that is an equal to a1 plus n minus 1 to d. So what is a1 here, that is 1. 1 plus n minus 1 into d. What is d in this case? That is into 1 multiplied by an, same formula, so 2 plus n minus 1 into d. What is the d in this case? That is also 1 into 1, and multiplied by a plus n minus 1 into d. D is again in this case third AP, also it is 1 into 1. Therefore, we can say that an is equal to, in the first case we will get 1 plus n minus 1 multiplied by 2 plus n minus 1 and multiplied by 3 plus n minus 1. So 1 and minus 1 cancel out. So therefore, we can get an equal to n into, here we will get n plus 1, and for the third number we will get n plus 2. So simplifying this, we will be getting an equal to n square plus n multiplied by n plus 2. Further simplifying it, we will be getting an equal to n square into n, that is n cube plus 2n square plus n square plus 2n. So therefore, we will be getting an equal to n cube plus 3n square plus 2n. Therefore, we can say that Sn equal to summation of an, and this will give us, therefore Sn equal to summation n cube plus 3 summation n square plus 2 summation n, and therefore Sn is equal to summation n cube means n into n plus 1 over 2 whole square, plus formula for summation n square is n into n plus 1 into 2n plus 1 over 6, and we are having plus 2 summation n, that is plus 2 into n plus 1 over 2. So 2 and 2 cancel here, 3 and 6 cancel, we will be getting 2. Now we can see that in all the three terms n into n plus 1 is common, so that we can take out. So therefore Sn equal to n into n plus 1, taking out common from all three terms, what will remain here is n into n plus 1 over, because we have taken only this square is there, so it will become 4. and plus from here what will because we have taken n plus 1 common, remaining will be 2n plus 1 over 2 and plus here in this one also we have taken n to n plus 1 common, so remaining will be 1, so plus 1. So this is what we'll be getting. Now we'll further simplify this and see what we can get. So simplifying this further, we'll be getting Sn equal to n into n plus 1, and this will become n square plus n over 4 plus 2n plus 1 plus 2 over 2, and that will give us, so simplifying this further, we will be having, let us simplify this further, Sn equal to n into n plus 1, and here we'll have n square plus n plus 2 into 2n plus 3 by 4, and this will give us Sn equal to n into n plus 1, and this will become n square plus n plus 4n plus 6 over 4, and we'll be getting Sn equal to n into n plus 1, n square plus, this will become 5n plus 6 over 4. Simplifying this further, we will be having, let us simplify this further, so Sn equal to n into n plus 1, and we can factorize this quadratic polynomial. So what we'll be having is n square plus, if you multiply this n square with 6, we will get 6n square. So splitting that, we will be getting 3n and 2n. So that will be our split, n square plus 3n plus 2n plus 6. Because when we add them, we will be getting 5n. When we multiply them, we get 6n square. That is the same as n square into 6. So divided by 4. Therefore, Sn equal to n into n plus 1, and here we can take out in this n common, so n into n plus 3 plus 2 into n plus 3 over 4. Therefore, Sn equal to n into n plus 1, and from here we will be getting n plus 3 into n plus 2 over 4. So this will be our answer for the question number 2. So this is the answer of question number 2, and with this it is complete. Now question number 3, we have to find the sum of the series 3 into 1 square plus 5 into 2 square plus 7 into 3 square plus so on. Here also we can see that each term is composed of two numbers which are multiplying with each other. So if you see the first number in the first term, that is 3, the first number in second term, that is 5, first number in third term, that is 7, and it forms an AP. Similarly, see the second term, it is 1 square, here is 2 square, 3 square. So if we just neglect the exponent, then we see that 1, 2, 3, they are also in an AP. So that is how we can find the nth term. Very simple. So here an equal to, that is nth term of the AP, nth term of the AP 3, 5, 7 and so on, multiplied by the nth term of the sequence 1 square, 2 square, 3 square and so on. And we'll be getting that therefore an equal to, how to find the nth term of an AP, that is uh, a1 plus n minus 1 to d. So 3 plus n minus 1 into d. What is d here? In this case 5 minus 3, that is into 2. And the second number is multiplying in each of the term, that is if we neglect the powers, that is also an AP. So first we will find the nth term of that AP when the powers are not under consideration, because when we consider the power under consideration, then 1 square, 2 square, 3 squares, it is not an AP. But when we do not consider that the exponents in each of the terms, then they will be an AP. So here for 1, 2, 3, that means in nth term it will be n, and of course power is there, so n square. So this is how we get the nth term. So an equal to, simplifying this, we will be getting 3 plus 2n minus 2 into n square. This will give us an equal to 3 minus 2 is 1, so 2n plus 1 into n square. And further we will be getting an equal to 2n into n square, is 2n cube plus n square. Therefore we can say that Sn equal to summation of an, that is this implies Sn is equal to 2 summation n cube plus summation n square, and this will give us equal to, Sn is equal to 2 summation n cube is n into n plus 1 by 2 whole square, plus summation n square is n into n plus 1 into 2n plus 1 over 6. So therefore we can say that Sn is equal to, from both we can take out n into n plus 1 by 2 common. So this will become 2 into, first let us simplify this one, so that will be better, 2 into n plus 1 over square, and this is 4. 4 can be written as 2 into 2. So plus this 2 and this 2 will cancel out, and we can write this as n into n plus 1 into 2n plus 1 over 6. Therefore Sn equal to, now from both terms we can take out n into n plus 1 by 2 common. So n into n plus 1 by 2 common. So what will remain here is n into n plus 1 plus, and from here what we will get is 2n plus 1 over 3. So simplifying this further, we will be getting Sn equal to n into n plus 1 over 2 n into n plus 1 over 2, and this will become n square plus n, that is 3n square plus 3n plus 2n plus 1 over 3, and this will give us Sn equal to n into n plus 1 over 2, it will become 3n square plus 5n plus 1, 3n square plus 5n plus 1 over 3. So now if we multiply 3 with 1, we will get 3, and whatever we do, we will be not getting 5. So this will be our final answer of this uh, question number 3. If you want, to just multiply 2 and 3 as 6. Otherwise this will be our final answer. So if you want, we can write it like this: Sn equal to n into n plus 1 into 3n square plus 5n plus 1 over 6. So this will be our final answer of the question number 3.